Hello my dear students, so I am going to continue with the lesson. We started the preparation, properties and uses of gases. In the previous chapter, I discussed how we can collect hydrogen gas, what their properties are and their uses. So now we will be discussing how we can prepare and collect oxygen gas in the lab, their physical properties and their uses. So oxygen, as regards the composition of normal air, about 20% of it is oxygen gas. So this is something that is familiar to you students. If you take the atmospheric air, you can remember students, 78% of nitrogen, there is about 20% of oxygen gas and there is 0.03% of carbon dioxide gas. And there are other noble gases as well, a certain amount, and there is water vapor that is also there. So out of that you can see oxygen, there is 20% of oxygen in the atmosphere. And it is very, very useful to us. We use it basically every day, 24 hours a day. When we breathe in and breathe out, we breathe in oxygen. So it is very, very vital for all the living organisms. Respiration, then combustion, so many uses. So students, if we look at the physical and chemical properties of oxygen, first we will consider the density of oxygen. Now oxygen is more denser than air. Oxygen is more denser than air. So that is the first property. When we consider the density, it is more denser than air. That is the first property that you need to know. Then if we look at the relative molecular mass, how do we calculate the relative molecular mass? You can see here it is 20% oxygen. So that is O2 molecule. You can remember, if we take oxygen, the relative atomic mass of oxygen is 16. So if it is O2 molecules, a diatomic molecule, you all can remember there is a double bond also between the two oxygen atoms. It is a diatomic molecule. When it is a diatomic molecule, how do you calculate the relative molecular mass? Oxygen 16 into 2, so that is 32. So relative molecular mass is 32. There is no unit for relative molecular mass. If they ask you for the molar mass of oxygen gas, molar mass of O2, that is also 32, but there you need to give the unit grams per mole. We have discussed that in one of the previous lessons. So you can remember that. Relative molecular mass is 32. Then combustion. If we consider combustion, combustion is burning of something. So for combustion to occur, we need to satisfy certain conditions or certain factors are needed for combustion to occur. What are those? One thing, we need to have a combustible substance. Anything that can burn. For example, paper or wood, even cloth, materials or a fuel like petrol, kerosene, diesel, all these are combustible substances. Then for these combustible substances to burn, you need to have oxygen. Oxygen is a must for combustion. So that is why we say oxygen is a supporter of combustion. It is a supporter of combustion. Then when the combustible substance and oxygen, that is the supporter of combustion, are there, we need to reach the combustible temperature or the ignition temperature. Then only the combustion will start. So there has to be a certain temperature. Those are the things that we need for combustion to take place. Combustible substance, supporter of combustion and the ignition temperature. So because of that, when we consider combustion, oxygen is a supporter of combustion. O2 is a supporter of combustion. That is a very important property. All the properties are important. This is something that you have to remember, students, because we use that for many of the purposes in our day-to-day life. Then solubility in water, they are slightly soluble in water. Oxygen is slightly soluble in water. Slightly soluble in water. And then if you see, it is a colorless and odorless gas. No color, no odor. So those are the physical and chemical properties of oxygen. The density is more denser than air. And the relative molecular mass is 32. It is the supporter of combustion. It is slightly soluble in water and it is a colorless and odorless gas. So those are the properties, and you know there is about 20% of oxygen in atmospheric air. So then I will move on to the next slide where I discuss some reactions that can be used in the laboratory in order to prepare and collect oxygen gas. So for that, we need to have certain reactions. Some reactions by which oxygen can be prepared in the laboratory are as follows. So here you will see, students, in all these reactions, we need to heat the reactant. And there is only one reactant. We will heat them. They will decompose and liberate oxygen gas. So these are going to be chemical decomposition reactions. We will write those reactions first. The first one, heating potassium permanganate. You know the chemical formula of potassium permanganate, KMnO4. When you heat that, you get K2MnO4. That is potassium manganate, K2MnO4, plus we will get MnO2 and oxygen gas. So here, if you look at the equation, you need to balance it. For that, we need to put a 2 in front there. Now, if you check 2 potassium, there are 2 potassium atoms, 2 manganese, 1 manganese, 2 manganese. Then there are 2 into 4, 8 oxygen atoms. Here you can see 4 oxygens, 2 oxygens and 2 oxygens. So now the reaction is balanced. So I am sure, students, if you remember the decomposition reaction, when you have potassium permanganate, you need to remember the products. Potassium manganate, manganese dioxide and oxygen. You need to know their names as well. Potassium manganate, manganese dioxide and oxygen. So that is the heating of potassium permanganate. Then we have the second one, heating potassium nitrate. Potassium nitrate is KNO3. So here also we are going to heat it and you will get potassium nitrite, KNO2. That is potassium nitrite. There we will get oxygen gas. KNO2 is potassium nitrite and oxygen gas. Again, to balance it, we need to put a 2 here and a 2 there. That is the balanced chemical equation. So here 2 potassium nitrate giving rise to 2 potassium nitrite and oxygen gas. You have to remember this. And if you check also, you can see these are balanced reactions. Then we have the third one, decomposition of hydrogen peroxide. You are familiar with that also. What is hydrogen peroxide? H2O2. There also we can heat it. Otherwise also it decomposes, but usually heating accelerates the reaction. You will get water and oxygen gas. So here also we need to balance it by putting the coefficient 2 in front of hydrogen peroxide and in front of water. So 2H2O2 gives rise to 2H2O plus O2 gas. Then the fourth one, Last reaction is heating potassium chlorate. Potassium chlorate is KClO3. So there it decomposes to give rise to KCl plus O2 gas. KCl is potassium chloride. So here again to balance it, we need to have 3 oxygens, but you need to have 2 potassium chlorate and 2 potassium chloride. So that is again is a balanced chemical equation. So those are the reactions. Now all these are balanced chemical equations, students. You can see all of them have one reactant which decompose on heating to give rise to the products, and in all the reactions oxygen gas is produced. So all these are what? They are chemical decomposition reactions. So for all the reactions, you need to supply heat. And for your knowledge, students, I will give you all the names of those products that are formed that you may not be very familiar with. Most of you all might know it, but in case you don't know the names, K2MnO4 is potassium manganate. So here you can see this is potassium permanganate, this is potassium manganate. And MnO2 is manganese dioxide. So in case in a question when they mention the names, you all should know what those substances are. Then we have KNO2. KNO2, that is potassium nitrite. So there it is nitrate, potassium nitrate, KNO3. KNO2 is potassium nitrite. You have to be careful with the spellings. Then hydrogen peroxide, water, oxygen, you all know. This is potassium chlorate, and KCl is potassium chloride. I am sure you all know that as well. Potassium chloride. So those are all the reactions related to production or preparation of oxygen gas. And all the reactions are chemical decomposition reactions. You should know their balanced chemical equations for all 4 reactions. Is that clear to you all? So with that, students, I will move on to the next slide. So here we have the activity collecting oxygen gas in the laboratory. And for that we need all these materials. So here also, if I write from this side, we need the stand. Then we need glass tubes, or what we call as delivery tubes. Then we have the other materials. Now here we need boiling tubes. Then we have the rubber stopper. Or here also you can use a cork. Here the diagram that shown is a rubber stopper. Instead you can use a cork stopper also. Then we have to have test tubes. Then we need a rubber tube. And here we need to have a trough with water. We need to have a Bunsen burner. Then in this activity, we will be using potassium permanganate. Permanganate. So what is the other common name given for potassium permanganate? We call it Condis. You all are familiar with that as well. Condis or potassium permanganate crystals are needed. If we don't use potassium permanganate crystals, we can use one of the other chemical substances like potassium chlorate or hydrogen peroxide, potassium nitrate. Any one of those can be used. But here we use potassium permanganate crystals. So these are all the materials that we need. In addition to that, like I explained to you all in the preparation of hydrogen gas, we need two more apparatus or two more materials. One is the beehive shelf. Again, if I draw the structure, you can see it when I explain the apparatus. Beehive shelf is something like this. It can be made up of ceramic or it can be a metallic structure. There is an opening here and there is an opening there so that you can direct the gas that is evolved during the reaction into the gas jar. So we need a beehive shelf. And also we need a gas jar. A tall jar like that. It is the gas jar. So all these materials are needed to collect oxygen gas in the laboratory. So with that understanding, I will move on to the next slide where I explain the diagram to you all students. So here, this is the method. First I will label all the parts and then I will explain to you all. So here, as you can see, this tube is the delivery tube or the rubber tube. Here we can use it as the delivery tube. So here of course it's going to be the rubber tube. And in here it will be the oxygen gas. And this is the gas jar. Here we have inside it is water. So here the arrow points to this beehive shelf. Beehive shelf. And this is the trough. So you just need to look at where the arrow points. Here of course it points to water. So I have marked it as water trough, or else you can write it as trough containing water as long as you know what that is. And here at this point we will have the glass tube. Glass tube, that is the full glass tube. It is bent in this manner, so that is what we call as the delivery tube as well. And here we have the rubber stopper. So here again we can have the rubber stopper. Rubber stopper. Or you can have a cork stopper. That is needed there. So on this side, if we look at the diagram, we need to have the boiling tube. Why? We are holding it to the flame. So we need to have the boiling tube. And here we have the KMNO4 crystals or potassium permanganate crystals. Then you can see the Bunsen burner. And here we need to have the stand, the laboratory stand, so that you can clamp the boiling tube. So this is what we do, students. We need to have the boiling tube. Into that we take potassium permanganate crystals. You all know normally potassium permanganate is purple in color, but when you look at the crystals, it looks very dark purple, so it almost looks like blackish color. It's not black in color, but the way it looks. So you know that. You have seen that in the lab. You take that into a boiling tube because we need to heat it. So we need to set the Bunsen burner like that. And then because it's difficult to hold the boiling tube, we have to clamp it into a stand so that it is held in place properly. Then we need to have the rubber stopper, and here we have to use the glass tube, and also we can connect the rubber tube. Otherwise, we can use the glass tube itself. But normally for the delivery tube, it's easier to have the glass tube at the beginning and then the rubber tube. Then only it's easy to pass it through the beehive shelf. Then we have the trough containing water. In that we place this beehive shelf, and on that, before placing the gas jar, we need to completely fill it with water. You fill the gas jar with water. You can cover the mouth with a watch glass or a glass plate, just a piece of glass, nicely finely cut piece of a circular piece of glass. So we have the cover glass there, so we can cover it with that. You bring it into the trough containing water, and without any gas bubbles or air bubbles entering into the gas jar, you have to place it on top of the beehive shelf. And then you can see, you can pass the delivery tube, insert the delivery tube through the beehive shelf. So when I showed you all the diagram, you will be seeing that in the lab. The beehive shelf has a hole at the top on the stage top. It has a hole opening, a circular opening, and on the side also there is a opening. So you can direct the delivery tube through that, so that it is easy for the gas to flow into the gas jar. So when you are doing the activity, if you don't have the beehive shelf, like I told you all in the previous chapter also, if you place the rubber tube and if you place the gas jar on top of it, there is a chance that the rubber tube can be pressed. So because of that, the gas cannot flow easily. So when you have the beehive shelf, it is easy to direct the gas into the gas jar. So that is the function of a beehive shelf. Then you have the gas jar filled with water. You have to make sure it is completely filled with water. Then you start the Bunsen burner. So when the Bunsen burner is burning, heat is provided. Because of that, the potassium permanganate crystal starts to decompose. At that time, you might be able to see some purple color vapor also there, but that does not come out in through this. Here the oxygen gas will come out. It will be delivered into the gas jar through the beehive shelf via the delivery tube. So here you will see the water level going down and the gas getting collected there. Thereafter, we need to confirm that it is oxygen gas. So for that, what we do is we need a dry eagle or a glowing splinter. That is also a material that is needed. Here we haven't included the dry eagle, so that is also needed there. Dry eagles. So there what we do is we use the dry eagle, we hold it to the flame. Once it starts burning, then we put off the flame and we have to have the tip of the dry eagle glowing. So that is what we call as a glowing splinter. Like we did before, first we collect oxygen gas into the gas jar. When we can remove the delivery tube, we can collect a little amount of oxygen into a test tube as well. We can hold a test tube underwater, a test tube again filled with water, hold it underwater, and you can insert the oxygen gas into that, and thereafter you can insert the glowing splinter. There is no flame, only the tip will be glowing. And when you observe, if it rekindles or if it relights and burns with a flame, then we know that the gas that has been collected is oxygen gas. So that is how we confirm that we have collected oxygen gas. So this is the setup, students, the apparatus used to prepare produce and collect oxygen gas. So again, the considerations. So KMNO4 is taken into a boiling tube because it has to be heated, and you all can remember it is clamped to a stand so that you don't have to keep holding it. Then the next one, gas jar has to be filled with water and placed on the beehive shelf without trapping any air bubbles. And also beehive shelf, all what I explained to you all students, what I explained before, I am giving it to you all now. Beehive shelf helps to direct the gas into the gas jar via the delivery tube. So another thing, again we will be collecting the gas. There you will see the water level going down and the gas bubbles going up and collecting above the surface of water. So in this method, oxygen gas is collected by the, what is the name given? We displace the water down. Water is pushed down and get the gas goes up. So it is the downward displacement of water. How is this possible? Because oxygen is less denser than water. So it pushes the water down and gets collected over water. But it is slightly soluble in water, but the amount of oxygen that dissolves in water can be negligible. Or else what we can do is, initially when we see the gas bubbles coming, we can just saturate the water with oxygen. So the maximum amount of oxygen will dissolve in it, and also thereafter we can collect the oxygen gas. So as long as we are not measuring the volume of oxygen collected, then of course it's not going to be a problem at all. We need to collect a certain amount of oxygen gas. That is our aim. So there, the solubility, slight solubility of oxygen in water does not become a problem. So we collect it using the downward displacement of water. And also, when a glowing splinter is inserted into a test tube. It can be a test tube or even the gas jar containing a gas. A gas relights. You can use the term relights or rekindles and burns with a flame. Then we can confirm that the gas is oxygen. So again students, I told you all there are different activities or tests to confirm the gas that has been collected. So in the previous chapter also, when we wanted to confirm that it is hydrogen gas, we used a burning splinter. There was a flame in the dry eagle. So that is a burning splinter. But here we use a glowing splinter. That is important. We hold the eagle to the flame, and once it starts burning, we put off the flame, but the tip of the eagle, the end of the eagle has to have a glow. It has to have the burning nature. So it is a glowing splinter, not a flame. So then only we can confirm that the gas is oxygen. So these are all the considerations, students. I will go back and quickly go through these. Here you can see this is the apparatus. So when they are given the diagram, you should be able to identify all the parts and label them, and you have to give the correct labels. That is something needed. So here we are using potassium permanganate or Condes crystals to produce oxygen gas. Then here you can see, since we need to heat the Condes crystals, we have to use a boiling tube, not a test tube. I am sure you all know that. And also, the gas jar has to be filled with water and placed on the beehive shelf without trapping any air bubbles. That is also important, so that we collect only oxygen gas, nothing else. It's not mixed with air, only oxygen gas. Then we have to have the beehive shelf. This actually helps to direct the gas into the gas jar. It has to be gas jar. This has to be gas jar. It has to gas into the gas jar via the delivery tube. And in this process, what is the method that we use? In this method, oxygen gas is collected by the downward displacement of water. So you have to remember that. What is the reason there? Because oxygen is less denser than water. That is the reason why we are able to collect it by the downward displacement of water. Then we have the test to identify or confirm it is oxygen gas. When a glowing splinter is inserted into a test tube containing a gas, it relights or rekindles and burns with a flame. Then we can confirm that the gas is oxygen. So that is all the considerations related to this activity. So I'll move on to the next slide where I discuss the method again, and then we will do the activity in the lab. So method, set the apparatus as shown in the figure. So I have labeled all the parts there. Collect oxygen gas to a few test tubes. So here also, like we discussed for hydrogen, you can collect it in the gas jar, so that you observe the downward displacement method properly with the beehive shelf and all that. And also you can collect it into a few test tubes that you can easily test it with the glowing splinter. Then do the following test to identify oxygen gas. So here this is the test to identify oxygen gas. Take a dry eagle, light one end of it. When the tip is glowing, put out the flame. So that is when the tip is glowing. Take one test tube with oxygen out of water and introduce the glowing splint. So, glowing splint or glowing splinter, it refers to the same thing. Into it as soon as you open the mouth of the tube. And then you can observe what happens there. So, that is the activity, students. I am sure you all can understand the procedure, all the considerations. So, when I do the activity in the lab, you all can observe all these carefully. So, now I will go to the lab and do the activity. Okay, my students. So, now we will see how we can collect oxygen gas in the laboratory and how we can identify that the gas collected is oxygen. So, to do the activity, these are the materials we need and you all know those. So, here I have a spirit lamp. So, that is instead of a Bunsen burner, we can also use a spirit lamp. Then you can see here a boiling tube. Since we are going to heat it, we need a boiling tube. We won't be using a test tube for that purpose. You all know the reason. Boiling tube can withstand heat. So, that is why we need to use a boiling tube. Then inside the boiling tube, you can see there I have already taken potassium permanganate. Now, here you can see, students, this is potassium permanganate or condis, the crystals of potassium permanganate. You all know the color, although it looks like black color crystals, but the color of potassium permanganate when we dissolve it is purple in color. So, we will be using that. So, the reaction that we are going to use here is the decomposition of potassium permanganate. Then I have the trough containing water so that we can collect the gas. So, then you all know, students, we need to have the beehive shelf. Like I have explained to you all before, now you can see this is the shelf with an opening here. Through that the gas can enter into the gas jar filled with water. And here there is another opening through which we can insert the delivery tube. So, the gas will be easily directed into the gas jar. So, that helps us to collect the gas easily without the rubber tube and all that being bent or pressed to the surface. So, that is the use of beehive shelf. Then we have the gas jar here. We will have to fill it completely with water. Like I have told you all before, we can either fill water into the gas jar, cover it with this glass, and then we can invert it like that and insert it into the trough containing water. Or else I can fill it inside water itself. Then we have the either a dry eagle or we can use a incense stick like this in order to get a glowing splinter. When we say glowing splinter, we hold it to the flame when it starts burning, and when we see the tip of the eagle or the incense stick glowing, we put off the flame and that will be the glowing splinter. So, first I will fill the gas jar with water. So, we have to make sure that there are no other gas bubbles trapped inside, so that we collect only the oxygen gas. Then we need to place the beehive shelf, and on that, without allowing any air bubbles to enter in, we need to place the gas jar. So, this is how we set it up. Then here we have the everything ready, the boiling tube. We will be connecting this stopper with the glass tube and the rubber tube. So, I need to insert the rubber tube into this. So, if I insert it like that, and when we start the spirit lamp, you can see the gas collecting. So, now we are heating potassium permanganate. You all can observe what happens there. Initially, you might see a few fumes coming up, the dark colored fumes that is also visible. And then you can see here, as I am describing itself, you can see the gas bubbles evolving. So, you can see the gas bubbles. This is oxygen. It's lighter than water, less denser than water. So, it goes above and displaces the water down. It gets collected over water. So, we call this process as the downward displacement of water. You can see the reaction occurring quickly and the oxygen gas getting collected. And here also you can see the decomposition process. A small amount of the potassium permanganate is also getting vaporized. That's why you see a color as well, a light color, light purplish color. So I can remove this. So now I have completely filled the gas jar with oxygen. So then I will be using this glass to cover the gas jar and take it out of water so that we will have oxygen here. So students, I will take it out of water. Now that it is covered, oxygen will not escape from there. There's only a small amount of water left. That is not a problem. So we will need a glowing splinter. We need to light it. So here students, if we insert this glowing splinter, you will see the observation. Can you all see? It rekindles or relights and burns with a bright flame. So that is because there is oxygen gas. And oxygen gas is a supporter of combustion. So that is why it rekindles. Okay students, you all saw how the decomposition of potassium permanganate or Condis takes place and oxygen gas is evolved, and that was collected by the downward displacement of water, and then again we use the glowing splinter to test that it is oxygen gas. So when we insert the glowing splinter, it relights and burns. So that is because oxygen is a supporter of combustion. So you were able to understand the process of collecting oxygen by downward displacement of water and testing and confirming that it is oxygen. Okay students. So I am sure you would have observed what happened during the activity. You all were able to see how I connected all the setup, the apparatus to collect oxygen gas, and how we fill the water into the gas jar, then how the oxygen gas gets collected by the downward displacement of water, and you were able to observe it was delivered through the delivery tube via the beehive shelf. So all that was very visible to you all. You all were able to observe everything. So now, if we write down the observation, when we heat the potassium permanganate crystals, you see the gas bubbles entering through the water and going up along the gas jar, and the water gets pushed down and the gas gets collected above the water surface. So that is what you were able to observe during that activity. Then we collected oxygen into a test tube when I inserted the glowing splinter. Glowing splint or glowing splinter, you were able to see that it relights and burns. So from that, we were able to confirm and conclude that we produced oxygen gas during the decomposition of potassium permanganate. So those were the observations and the conclusions that we can get from this activity. So if I write that down, observation, gas is collected above water in the gas jar, and the water is pushed down, or you can say displaced down. Then when tested with a glowing splint, so as I told you all, we can use the word glowing splint or glowing splinter, that is the dry eagle with a glowing end. When tested with a glowing splint, it relights and burns. So those were the observations. So from that, we can conclude oxygen gas is released when potassium permanganate undergoes decomposition. Or you can say when potassium permanganate is heated. You can write it anyway. So that is one conclusion. Then the next one, O2 gas is collected by the downward displacement of water. Then what happens? We did the activity to confirm that it is oxygen gas. So when inserted into the test tube containing the collected gas, the glowing splinter is rekindled. This confirms that the gas collected is oxygen. So those are the confirmations. So here gas is collected above water in the gas jar and the water is pushed down, so that is downward displacement, or we call it displaced down. Water is displaced down. So when tested with a glowing splint, it relights and burns. So from that we came to these conclusions. Oxygen gas is released when potassium permanganate undergoes decomposition or when potassium permanganate is heated. Then oxygen gas is collected by the downward displacement of water, and also when inserted into the test tube containing the collected gas, the glowing splinter is rekindled or relighted. So this confirms that the gas collected is oxygen. So those are the observations and conclusions of the activity. And also I have explained all the considerations, all what you need to remember there. So I am sure you all can remember all those and you have understood and you have observed everything as well. So with that, students, I will move on to the next slide. So here we discuss the uses of oxygen. Again, I have given all the diagrams. You can see here the first one. when I started the chapter itself, when we discussed oxygen, I told you all about 20% of atmospheric air is oxygen. And we use that every day, 24 hours a day when we inhale oxygen. So, for breathing of all living organisms, oxygen is required. Then the other use, we use that in our day-to-day life, combustion. For cooking, to provide heat, for many purposes, even industrial purposes, even in the extraction of iron, we saw we need combustion. So, there air is needed, that is oxygen is needed for combustion. So, it is a supporter of combustion. Then, oxygen is filled into cylinders. Oxygen cylinders, you are familiar with that. Who are the people who use oxygen cylinders? Deep sea divers use it, mountain climbers use it, then people who go to outer space, they use oxygen cylinders. Even in the medical field, in the hospitals, there are patients, sometimes they need oxygen. So, there also we use oxygen to fill cylinders, and that is used for again breathing by different people. Then we have this. You would have seen this happening, welding process. For welding, to get this flame, the bright flame with high temperature so that the iron or steel can melt and can be fused together, we use oxyacetylene flame. So, when we say oxyacetylene flame, there is oxygen gas and acetylene gas mixed together, and that gives rise to this oxyacetylene flame. Then we have this. Here, of course, I have shown a bottle of nitric acid, HNO3. Similarly, we can produce sulfuric acid. So, for the industrial manufacture or industrial production of nitric acid and sulfuric acid, we need oxygen gas. It is used as a raw material. So, these are some of the uses of oxygen gas. You need to know them. I will write them down one by one. So, the first one, it is essential for breathing of organisms. Then it is necessary for combustion. That is, it is the supporter of combustion. You have to remember these, students, it is the supporter of combustion. We discussed this with the properties of oxygen as well. So, then oxygen gas filled into cylinders are used by deep sea divers, space travelers, mountain climbers, and in the hospital for patients when needed. So, those are uses of oxygen cylinders. Then, oxyacetylene gas used for welding uses oxygen gas. So, oxyacetylene flame, acetylene or acetylene, oxyacetylene gas used for welding. Oxyacetylene gas that gives rise to oxyacetylene flame. So, here the gas actually burns and provides the oxyacetylene flame. So, that also uses oxygen gas. And finally, we have the manufacture of nitric acid and sulfuric acid uses oxygen gas as a raw material. So, these are some uses of oxygen. You can write the uses in your own words as long as you give the correct use. So, the oxygen gas, it is essential for breathing of organisms. People and other animals, even plants, they all breathe, they inhale oxygen. So, that is essential. Then it is necessary for combustion. So, whenever there is a flame, when there is something burning, we need oxygen, and that is why we call it the supporter of combustion. It is a requirement or it is a factor necessary for combustion. One of the conditions that needs to be provided. Then we have oxygen gas filled into cylinders. When we have the cylinders, those cylinders are used by deep sea divers, space travelers, mountain climbers, and in hospitals for patients when they need it. And then we have the oxyacetylene flame. So, there it's the mixture of oxygen and acetylene gas. Mixed together, oxyacetylene gas gives rise to the oxyacetylene flame that is used for welding. That uses oxygen gas. So, then we have the manufacture of nitric acid and sulfuric acid. It also uses oxygen gas as a raw material. So, those are the uses of oxygen gas. So, with that, students, I will end this chapter, and in the next chapter, I will discuss the properties of carbon dioxide gas. Then we will see how we can prepare and collect carbon dioxide in the laboratory, and then we will discuss the uses of carbon dioxide. So, with that, I will end this chapter.